afternoon, everyone. It's a pleasure to be along with you here today. And we're hearing great talk from the morning. So since it's Construction Technology Festival, let's go a little bit more technical and talk about one of the most promising technology, which is the 3D printing in construction. So before I hit on that, I just need to make sure that we all understand the difference between green building and sustainable building. We all blame construction more than enough to be in charge of 1/4 of the carbon CO2 emission globally, and we all know it's because of the material composed in the construction. So the green building are the building which is acting against reducing these figures, which is the CO2 emission. But when we talk about sustainable building, which mean we are making a bit more broad approach, where it fit in the 3 pillars of sustainability. It add more on the people in terms of well-being and also the profit, which is the economic factor of the construction. Construction industry is the one producing this product, and in order for construction industry to be sustainable, it needs to fit within the 3 aspects of the sustainability, which is reuse, reduce, recycle. This terminology looks like the same. However, there is a great difference in between because the sustainability has more concepts to consider, just more than being environmental friendly. So, is this 3D printing viable solution? Before we go on that, let me make sure that you all understand what 3D printing is in terms of value. We call the 3D printing as the 3rd industrial revolution. The first industrial revolution was the automation, introducing the machine to replace some of the human effort, and that was happened in the 18th century. Second one is the mass production, which means putting the machine in a production line. It has a great impact in terms of economic efficiency. If I want to speak in the construction language, we can see this mass production mostly in the prefabrication, off-site manufacturing, precast or modular construction. We are hearing great talks in the morning about this. It has a huge impact in terms of being environmental friendly and saving the time. However, in order to be cost efficient, it needs to have a large amount of repetition. We need to standardize. Any small design variation or any small design change is very costly when we talk about off-site fabrication. And here the 3D printing comes. It helps us to use the same concept from before. However, it gives us the advantage that we don't need to stick to repetition. So every piece can be a masterpiece. And here is the great value of 3D printing is. Please choose 3D printing to your project when only can add value. 3D printing cannot replace off-site fabrication or a precast. If we talk about a similar villa which you are trying to do 100,000, it won't make difference. Actually, 3D printing cannot be competitive. So, is it a really environmental friendly product? Actually, there is a big debate because if they talk about only that environmental aspect and they look on the CO2 emission, there is even some debate that 3D printing can be more more CO2 producer because it uses more cement. The cement content is higher, and it claimed that it will not need reinforcement, but still it needs reinforcement, as we will see later. So from that aspect, it's not that much environmental friendly. However, we need to look on the bigger picture, as we said at the beginning, that being sustainable does not mean only being green. Now, in all the projects done in 3D printing so far are pilot projects, cannot be taken really for that kind of a comparison with the commercial project. However, in order to give some idea where we are, I just sharing on the screen this study. Actually, this is a comparison between 3 individual studies, which done in comparison between the 3D printing and conventional method in 3 different regions. One of them even here in Saudi Arabia, the one you can see in the gray. And we can see from the terms global warming, it's a bit competitive with the conventional. It's very close and even can be better if we use a renewable energy for the machine operation rather than being the fossil fueled one. However, in all other aspects, as you can see in the screen, it's adding much more value. And if we put this in one bowl and we look on how much improvement can happen through using 3D printing, we can see it can add up to more than 60% being better sustainable product than the conventional method. So, it is so good, why it's not spreading that much faster as we were expecting before? Actually, there are certain limitations, and this limitation all happening against the standardization of the process. We are not able to reach the standards or the regulation which can regulate this technology. And To understand why, I'm going just to share with you some of the pain point where those technology providers are facing now in order to understand why they are not able to standardize. Let's being a bit more technical here. So for us, in order to be able to produce this material from the machine, we need it to be workable material, very flowable. However, once it comes out from the machine, we need it to cure very quickly in order to support the next layer. And if that's not happening, it will happen what you see in the screen. Actually, this was one of our trials in our lab. This kind of collapse will happen when the layer cannot support the next layer. So, not only that, but also if we let it cure quickly, structural engineers will know that early strengths always act against final strengths. So that will make the concrete at the end weak and is not able to support the building. Now, 3 parameters are acting against each other. Let me add up also that the ambient temperature will make a big difference, and also the printing length, the time it will take from the machine to come to the next point. It will depend how far it will go and come back. All those factors are acting against each other. So to come up to one magic solution to serve all those aspects together is not going to happen. How those technology providers solving this problem? That they developing different scenario, different mix design and different printing approach for every scenario. Putting this in one standard regulation is not going to work. Next one is the tensile strengths. It depends on the direction where we test. We have a very good bond within the layer itself. However, the bond between layer to layer is affected by the pit-hole joint we talked about previously. So if we test in the direction within the bond, within the layer, it's very strong, but in between the layer, it doesn't have that same tensile capacity. And again, this will also relevant to the thickness of the layer, the width of the layer, and the property of the material which we use. Again, putting this in one standard is not going to work. And that's, again, one of the major constraints we have. Next one, we still are not able to make this product take a moment unless we put a reinforcement in. It's good in the compressive strengths, good in the normal forces. However, when it comes to bending moment, it's not able to act by itself, and we still need to add reinforcement. But adding this reinforcement also will have a lot of conflict with the direction how the machine moves. And whether this machine is moving on a gantry or moving on a robotic arm, again, this is going to impact how we can place this reinforcement in. And this, again, is relevant to each machine, how it operates. And again, this work against the standardization. We can't come to one single standard which can control all the machine because of this fact. One of the last points I'm highlighting today is also the absence of the regulation and the standard which can regulate this. Now, all the structural engineers have to use the structure softwares, ETAP, SAFES, PROCON to come up with a structure model where the authorities or other can also validate the structure integrity. But since we don't have a standard, we cannot embed this standard inside those softwares, and those software are not able to analyze this kind of structure. So this is again one of the major constraints we have. How to come over this? I will just share some of the ideas which we can just consider. So first thing, instead of standardizing the process, let's change the way we think. And let's standardize the product itself rather than standardizing the process. If we can develop a testing criteria on how this product can work, that's good enough for us to use the building rather than pushing the technology itself or the process itself to be standardized. We can have a testing criteria and all the different technology providers can work out to give us a product which can meet this testing criteria. A second way around that is instead of using the entire structure to provide the structure integrity, we can define certain elements and certain areas within the structure itself which can act as a structure element, and those areas we can still print or cast monolithically. Then we don't have this problem of interlayer tensile strengths. For example, such kind of column which is irregular shape, if we have a circular mesh inside, this only can be defined inside the model as a column. And the software can use this clearly in order to calculate as a simple finite element calculation. And the most important part which I would like to highlight here, rather than pushing technology to develop a structured software, structure skeleton, let's use the technology where it can add value. We are able to control the gaps inside this structure, and these gaps can be used for some other disciplines where we can integrate together. So we can use the gap for the air return, then we printed the duct. We can use to put the cable inside, then we printed the cable tray. We can put the admixture for waterproofing inside the mix design, then we printed the waterproofing. We can use it for adding pigment and develop a pattern or develop the certain architecture way, then we printed the insulation or printed the final finish. Adding all those disciplines or the other trades together with the structure can make this technology more competitive and can help it to spread furthermore. Now, before I end, I would like to share with you the photos which I'm hiding here. This kind of product which we can produce using 3D printing where the conventional way cannot produce, and this is the way how it can be competitive or even can take the lead. Let's use it where it can add the value, and this is the way where the 3D printing can prove itself and can spread further. By this, I'm ending my presentation. Thank you very much for listening.